functions, which is a review from probably higher algebra. Didn't you do it in higher algebra and in honors pre-calc? But just a quick reminder of the notation. We're going from A to B. This is a notation you need to be familiar with. xy is an element of f, of the function f, sometimes written x f of y. Or, and then you can see it right here too, y equal f of x and f equal f colon x. This is like set notation, the set of all f such that x maps to y. Now the idea of a function is that each x maps to how many y's? One y. Yeah, and the reason for that is it's kind of like a truth thing. I say I know this value of x, then I know there's only one truth for y. Okay, it isn't like you put a quarter in a machine and you get one day you get one Diet Coke, one day you get two. Now, I like those days where I get two Diet Cokes, but the machine isn't working if you get one day, two another. So we talked about one job, one pay too. If you have the same job and Elena's getting 15 an hour and Henry's getting $11 an hour, doesn't seem real fair. Except she's probably better at it. Is that possible? No, I'm just kidding. So when we're mapping, you have this domain, and this might be a new one for you, codomain and range. Would you put a little star next to these two? These, you got to know the difference. The codomain is all of what's in the second one. All of B is your codomain. So what is the range then? The ones that are mapped to A. Okay, so they might not be all mapped to it. So in this case, this first one, example, they have 1, 2, 3, 4. You can see the codomain is 1 through 4, but the range are only these. The range are only 1, 2, 3. Okay, these examples are really good. This one, we have a codomain of 1, 2, 3, 4. The range is 1, 2, 3. This one, the codomain is 1, 2, 3, 4, and there's only 1, 2, 3 as the range. So that codomain and range is going to come up again when we talk about surjections and all that sort of thing. Determine which each of the following is a function, just to remind you that if you ever see a repeater x with different y's, then it's not a function, right? This one's kind of interesting. The relation in R defined by if y is greater than x, could an x of 2, like x equal to 2, have more than one y pairs to it? Yeah, you could have 3, 4, 5 if you're looking at integers. Real numbers, 2.1, 2.1, 2.2. So this is not, okay, because, and I would even write 3 is greater than 2 and 3.1 is greater than 2. They're right there. It falls short. This relation looks good. 2, 3, 4. This relation looks good because each x is paired to one y, even though some of them are the same. Okay, we have this vertical line test, which is, again, each x has one y. So if you had two y's, then it would fail the vertical line test and it would fail the definition of function. So that's how you can do those. And I think you recognize that part isn't the problem, right? But injection, surjection, and bijection. Injection is a function whose inverse is a function. And this is what they call the onto idea. So if we're looking at a graph, the ones that will work will be this one. What can you tell me is the slope for this entire function f? what's the derivative always going to be? Greater than 0, right? Does it ever get negative? Then it's always increasing. So therefore, it's what we call one-to-one. It's an injection. We used to say the inverse was also a function. You could also do this going the other way. F prime of x is always less than 0, so it's always decreasing. And so therefore, that's an injection as well. Inverse is also a function. Now, we had a shortcut for that. You remember? Horizontal line test. Is y equal x squared? Is that an injection? Nope, it wouldn't pass the vertical line test. It just means that the inverse is also a function. That's injection. Okay, and you can look at those examples. They're great. Surjection. The surjection is, it's onto, but it also uses all elements of B. In other words, nothing left behind. Okay. So like this one, this is probably the easiest. 1, 2, 3, 4 to B, 1, 2, 3. Is this, the way they've paired it, is this a surjection? Are all the elements of B being mapped to something in A? Yes. So this yes is a surjection. Let's look at some of these examples. Yeah, I like this one. But yeah. Let's look at y equal to 2x. Looks like that. F of x equal to 2x. But we're using integers, mapping to integers. Now, positive integers. So we don't need this bottom part at all. This one's kind of cool. Watch this. So what are some positive integers we can use? 1, which will get me 2. 2, which will get me 4. Let's just start with those. What can't we get? We can't get a 1, a y equal to 1. I want a different color here. Can't y equal 1. What else can I get? Y equal to 3. Because if we're starting with integers, you'll always get an integer. It'll pass the horizontal line test, but you just won't be able to get all the odd numbers. So it would not be a surjection. But it would be an injection.
But then wouldn't that, wait, what is then B in that situation?
What is what?
Because couldn't B just be all even numbers? And then everything would be represented?
I think B is supposed to be every positive integer. Because
It says it's mapping to all the positive integers.
Oh, okay.
But the function is 2x.
So is it C, arrow Z, is A, arrow B?
Yeah, correct. Yeah, this is A mapping into B. Good. And so this one is going to pass the horizontal line test. It's an injection, but it's not going. It's going to have some leftovers that we can't get at. So then that's the surjection. And then the last one is the easiest of them all. If you have both an injection and a surjection, it's called a bijection. Like that last one isn't a bijection, okay, because it's not a surjection. And that's it. That's functions. And you can, I'll have you look at some of these examples. Let's take a peek at, let's look at A here quick. F of x equals x cubed. Is that an injection? Just by looking at it, is it an injection? Is it a function? Yep, and it's an injection. So that's good. When we look at real numbers, is it going to be a surjection? Each real number has a unique real cube root. it's a surjection or injection. Each real number has a unique real number, so F is a surjection. It's going to have all of them. Now, what if this were like Q to Q? Well, the problem with that is there are some cubed roots that you're not going to have as rational numbers. But you could put a rational number in for x, cube it, but you can't necessarily cube something to get a rational number. So, you know, it's not as simple as it looks. B, we're looking at reals mapping into reals. F is not an injection. Why? Is that an injection? Nope, fails the horizontal line test. F of -2, F of 2 equals 4. And then also, look at all the things that would be left out here for real numbers. All the negatives would be left out. So it wouldn't be a surjection either. So it wouldn't be an injection. It wouldn't be a surjection. It's like a double bijection failure. Sad. And then this last one, the positive reals mapping to the positive reals. This one's kind of cool because it is an injection. Why? I thought we said it wasn't for x squared. But why is this one an injection? It's only the positive ones here. So it's going to pass the horizontal line test. It's an injection. And if you're mapping to the positives, will you always have a real number positive that can map to everything? And that, yeah, you can. You know, again, if this were Q, it wouldn't. But if it's R, yes. You have irrational numbers that you can use. If, let's say you had 5 here, and you wanted x squared mapping to y equal to 5. Well, that's going to be the square root of 5. That's an irrational number. It is a part of the real numbers positive. So it would be a surjection. So if it's both, then we say it's a bijection. And there's some good examples here. I think we're good with those. And hoping we'd have yeah, let's do this number 3 as a group real quick. Diagram below shows map of functions 1, 2, 3, 4, 1, 2, 3, 4. And we just want to tell, is this one an injection? Are there any times, first of all, is this a function? Is every x going to 1y? Is every y going to 1x? No. So this would be a no because of the 2. 2's mapping to 1 and 2's mapping to 3. Well, actually, we would write it 1, 3. They're mapped in that order, 1, 2, and 3, 2. So that would be not an injection. Are there any not being used? Yeah, so this would be no as well. So this is a no. No, no, no. That one. How about this one? Does every x, is it a function? Yeah. Is the inverse a function? Or is, yeah. So this one's yes. Every y goes to 1x. Are they all used up? Yep. So this one's a yes, yes, yes. Now you should be ready to go on these assignments.